Good morning everyone. Today we are going to discuss about Dynavit-Hartavan notation scheme. This notation scheme is given by these two people, that is Dynavit and Hartenberg, to find the kinematic relation between adjacent links. In today's lecture I am going to tell you about the different parameters they consider for finding the relationship between two links. Okay. First of all, for doing this, I am going to consider two principal axis frame at the different location, and the first frame is translated and then rotated by certain values. We are keeping both them as a constant. So over here, the first frame which I am going to create is a principal axis frame, that is x, y, z. I name them as x I minus 1. This is z I minus 1, and this is y I minus 1. Okay. Now after translation and rotation, this frame got a position over here, and this axis is represented by xi, this is represented by yi, and this is represented by zi. Okay. So for finding the relationship between these two parameters, what we have to do, we have to consider an intermediate frame over here, that is z axis over here, and I named as z dash, and this is x dash, and with respect to right hand thumb rule, the y direction is going to be within the screen, so this is y dash. Okay. So for finding the relation between these two links, we have considered an intermediate frame between these two frames. So for finding the relation between Dynavit-Hartenberg notation scheme, what we have to follow, first of all, we have to translate. I am going also name these origin. This is O I dash, sorry, I minus 1. This is O dash, and this is OI. Okay. So the first step which we have to do, we have to translate in z direction, and this distance is going to be represented by di, and this is called as joint offset. Okay, I am writing the short form, that is joint offset. Okay. And the homogeneous transformation matrix which we have to write, we show by T, and the direction in which we have do translation for finding or tracing the distance di is z over here. Okay. So this frame is going to reach to O dash. Okay. And when it is reaching over here, you can see that the x axis of OI minus 1 is over here, over this side, and the x dash is over here. Also, while finding kinematic relationship between two links, we have to find common normal between two joints. So over here I am extending backwards with this frame parallel to xi, and with the first frame I created a line parallel to zi minus 1. So over here we find intersection point. So the shortest distance between two frames is called as common normal. But there is one more condition, that this common normal should be perpendicular to both these frames. Okay. Now what we have to do, we have to rotate about z axis by some value, so that this xi minus 1 axis is going to be parallel with this x dash, and this angle is represented by when I am going to rotate this xi minus 1 axis to keep it parallel with x dash, I am going to represent it by this angle, and this angle is represented by theta I, and it is called as joint angle. Okay, and this step is going to be performed over here, so that this x I minus 1 is going to be parallel with this common normal. Okay, and the homogeneous transformation matrix which we write over here is doing rotation about z axis. Okay, now the next step is that we have to reach this second principal axis frame from this O dash origin. So what we have to do, we have to track a path between O dash and OI, and this distance is represented by AI, and this is called as link length. Okay, and the homogeneous transformation matrix which we have to write is represented by T, and this is the translation in x direction. So I am writing over here x. Now the last parameter of dynamic Hartree notation scheme is the twist angle. So for finding the twist angle, what we have to do, first of all we have to draw a line which should be perpendicular to common normal. Okay, then what we have to do, we have to do a rotation about x axis, so that this zi is going to be parallel with this perpendicular axis, and this angle is represented by alpha I, which is called as twist angle. Okay, this angle is called as twist angle. Now, and the homogeneous transformation matrix is written in such a manner that we perform rotation about x. After this, I am going to write the whole equation. So what we have done over here, we are trying to find the homogeneous transformation matrix of this I frame to this I minus 1 frame. So this is representation of homogeneous transformation matrix represented by T, capital T, and what we have to do, we are trying to find the relationship between this I frame and I minus 1. Okay, so what we have done over here, the steps which followed, the first step is that we do translation in z axis from origin I minus 1 to O dash, and the homogeneous transformation matrix represented by over here, and we do translation about z axis, and the parameter representation is represented by di, which is called as joint offset. Okay, now the next step which we have done over here is we do rotation about z axis, zi minus 1 axis, so that this I minus 1 axis is going to be parallel with this common normal. Okay, so the homogeneous transformation represented by this letter, and we do rotation about z axis, and the parameter representation is by theta I, which is called as joint angle. Now next step we have followed, we do translation about x axis, the homogeneous transformation matrix representation in x direction, and the parameter represented by ai, and this is called as link length. At last what we have done, we do rotation about x axis, so that the axis zi is going to be parallel to the line which is perpendicular to the common normal. So the homogeneous transformation matrix which we done over here, that rotation about x axis, and the parameter represented by alpha I. So this equation is given by Danavit Harterber, so that we can find relationship between two kinematic link which are adjacent to each other. There is one more thing I would like to tell you. If the both frames are lying with same origin, suppose there is a link over here in such a manner, and there is another link which is placed over here. So this is a revolute joint. Okay. So with respect to right hand thumb rule, the z axis is going to be drawn over here, the x axis is going to be in this direction, and with respect to right hand thumb rule, the y axis is going to be drawn in this direction. Okay. And with respect to this, if this is the link, if this motion is going to be done over here in such a manner, the z axis over here, the x axis should be perpendicular to this, and if this is going to be happen, the y axis comes out of the screen. Okay. So you can see that both these frames are lying within this with same origin. So with respect to this, the first value is going to be 0. So in such a manner we can find these parameters between two adjacent links.